such as planning for stormwater management. Okay, so some background on why we actually created this tool. So as we all know, green structure has emerged as a multi-benefit solution to address stormwater quantity and quality issues. However, at least in the Bay Area, I believe it's probably statewide, nationwide, the implementation of green structure has continued very slowly and optimistically. I think one barrier could be in a technical area is like there's a lack of watershed scaled systematically planning in regard to where the opportunity actually the site exists for retrofit, or what would be the quantitative benefit people can look at it, how much we actually can get from our investments, right? Those are information, people often find that lacking and they don't know what to do and then they don't really trust. The public haven't had that trust to say this thing is really working. So that's another reason. Also on the regulatory front, phase work permit in San Francisco Bay Area, they require the municipality to develop and implement, watershed-scaled green structure master plan to meet their TMDL requirement for PCB and mercury in the Bay Area. And also, state agency requires municipality to develop a stormwater resource plan in order to qualify for the funding, Part 1 funding for the stormwater project. So therefore, there is really a need to have a scientifically sound tool to help you for the long-term planning to identify the project site for your planning and management of green structure. So to meet this need, we have, 4 years ago, we get a POP 18.4 funding, and that's our first phase 1 development. So we start to develop this tool. So the tool has 4 components which are standalone. Each can use individually or combined together. So there's a GIS site locator tool, which basically is a serious GIS analysis to help you identify and prioritize a project site. And there's a modeling tool which to establish a baseline condition to quantify how much load stormwater runoff from the landscape, and to also help you evaluate the performance of green structure. And so also there's an optimization tool. So this one actually we use cost-benefit analysis to say, what would be the optimal combinations. You could have multiple sites, multiple types of LRD you can choose from. So how you figure out which one would be best, for you with a minimum cost. This tool will answer that question. And then we also added a tracker this year. So to those 3, the first 3 are planning tools to help you plan, but the last one is as you start the implementation, you need the tool to help you tracking where the green structure has been implemented, what are the benefits. So that's keep a digital record, moving forward. So this toolkit we call Green Plan is really robust and flexible. As I said, it's a modular structure, so therefore these 4 tools can either use individually or combined together to meet a range of stormwater management needs, from supporting your green structure planning to help with your stormwater resource plan, also support reasonable assurance analysis. So it's scientifically vigorous. It's developed, through the decades of experience and expertise of development team, and also oversight by the technical advisor committee as well as stakeholder groups through the development and application phase. And lastly, it's a public domain tool. So we posted online. I'll show the website later on, so everyone can feel free to download and use it for your own need. So this tool actually, so I think the use of tool, we see it can help you answer a number of really key stormwater management questions. One is, when start with, so you want to ask, what possible locations you can, implement your green structure in your landscape, right? That's the first question you face when you start to, develop either your plan or stormwater resource plan, watershed plan. So this is the first question the tool can help you. The second one, so it's like, what are the effective locations? We all know, so stormwater runoff and pollution are not generated uniformly from landscape, right? Some places are more pollutant than others. So you want to identify what we call either hotspot or high leverage area where your green structure will be most effective. You don't want to place really clean places where you actually do nothing, right? So this tool will help you with that information. And also, I think very importantly, you want to know what a quantitative reduction you can get in terms of runoff and the pollutant load. I think that's people often asking, you want us to put this much money, put this thing on the ground, how much benefit we can get. That's a very natural question to ask. So the tool can help you with that information. And fourth question is like, what would be most cost-effective combination in your landscape or your watershed to achieve a certain reduction goal? As I said, there's a variety of green structure types, LID, BMP, we call it, everything. So you can choose from. There's a multiple locations, so which ones, what the combination or in terms of what types are LT, how many you need them, what are the locations. So this combination, it could be numerous combinations, a lot of you can choose from. So this tool can help you set it out. So lastly, so we want to keep tracking where LD green structure has been implemented within either your city boundary, your watershed, or your regional, so that you have a record and you can also keep tracking what are their cumulative effectiveness. So starting with the site locator tool, I just gave a quick review of each of them. So this one basically is a GIS analysis. It's through a lot of a serious GIS analysis to try and help you identify potential locations for green structure. This is actually what basically referred to as a prioritization and identification of potential locations. The tool can take you from, when you face a large landscape or a watershed or city boundary, you say, like, well, I actually put something, where. So the tool can help you from not knowing where to put things to some very specific, feasible and direct locations based on your local priorities. So here, this tool is very flexible. It's customized. There's a lot of data can go into as many as you want, or as few as you want, the layers. So here's some example GIS layer we have been used for our case studies. So you have a street, you have parks, parks basically the place you can say, well, that's a potential location we can do something, right? A parking lot, we could put a permanent pavement there, or we want to stay away from the gas line. So therefore, we also want to stay away from places where have very shallow groundwater table. So this is the kind of analysis. Some will help you, a layer will help you identify what are feasible. Some will try to help you exclude some, unfeasible areas. So so it all depends. So you can use a subset of those layers, or you can even use more. So it's all like user defined. The output from this tool is a list of maps at both showing the potential locations for different green structures. So so you can do some regional analysis, large-scale regional analysis. This is what we call the East Bay Corridor in the Bay Area, which spans actually over 10 cities. It's a very large scale. So you can see a pretty coarse kind of analysis showing the potential places, all these blue places where you can put bioretention. You can also go very detailed at the watershed or city scale level analysis, which can show you the city block by block, all those locations, which street, along which street and which road and which park actually there's a potential location for you to green structure. So you can say it's a very flexible tool, can apply to different scales. So those locations identified could serve as a starting point for your green structure master plan, as well as your stormwater resource plan, right? So this could be, say, you have feasible location identified and also ranked, based on, remember, those blue ones is actually highly ranked, and the red one is like lower ranked. It's based on your local objectives and priorities. Basically, we work with city staff to let them tell us how you want to rank each of layers, which one are more important for you. So therefore, they totally reflect their performance. So this is the first tool. The modeling tool, we actually use EP with SWIM. I think probably some of you familiar with that. So this tool is to quantify the baseline hydrology and pollutant level, as well as to help you evaluate the performance of each green structure. So the tool can give, private you with ability to compare before after situation, right? Before here's our current situation, the after we have a GI build out. So this comparison will help you to quantify the benefit of green structure. So once the modeling tool is set up and calibrated to the local data, it can be used to, as I said, establish baseline condition. So this baseline condition is really important to help you identify critical, we call the rough and pollutant source area. So this is one of case study we did for PCB load. So the darker area, the higher PCB load. So obviously you want to put your green structure on those dark areas so you can reduce them. Load, right? So also the tool will be used for cost-benefit analysis to try to evaluate performance of different combination of green structure on the ground. And lastly, the tool can support, the modeling tool can support the reasonable assurance analysis. So remember the definition of reasonable assurance is really just to quantitatively demonstrate, your plan actually can meet certain reduction goals. So this tool can help you say, do the before after to say, here's how much. Once you have this plan put on the ground, how much reduction you can get. So this is a quantitatively demonstration. It can support that. So the optimization tool, this one, as I said, there could be a lot of tens of thousands actually for our study. You could end up with tens of thousands different combination of green structure types, numbers, locations within watershed. So this tool can help you determine what is the most cost-effective solutions to achieve your management goal with the minimal cost. The output from this tool we called is cost-effective curves. This curve actually show a relationship between the implementation costs and the various level of runoff or pollutant reductions. So each dot represent a combination of green structure types, numbers, and locations. So we call this the line on the front, we call the optimal front. So any point along those lines, we call it a more optimal solutions. So if, let's say, for example, we have this 30%, this red dot, we say we want to 30% runoff reduction. So this same solution can also achieve 56% load reduction. But if you move toward the right, you can see this dark line. So every point on this line can achieve the same reduction. However, they're associated with much higher cost, right? Between a good one and a bad one, the cost difference could be like 50 million or 10 million. So that's just meaning you could spend much more, but still the same benefit. If you look at it vertically, let's say I have 100 million I want to spend in this region, and so you can see from lower end of this orange graph to this red point, the difference could be 30%, meaning you could spend a whole lot of the same, but you get like 13% less of benefit. So this really shows, use the tool like that, highlight the need, a benefit of a tool like that to help you to sort out what could be the best option for you. Also, for each of the solution, you can visualize on the map. So this red dot represents how many number of spire rotations at different locations can achieve the overall reduction. So there's different ways to look at each optimal solutions. So lastly is the tracker. Tracker really just to help you keep tracking the green structure implementation over space and time, and report their effectiveness. This really is, we call it a regional online database, which has all these green structure features there with a streamlined process for reporting. So here is, the places, the location, so you can see the number of dots there with, so maybe look at this one. So anyway, so the tool can display to give you a maps of specific green structure locations for all your either planned, your potential, or your implemented project. So for each of this green, blue dot is represent one, facility or one installation. So you can click any of them. So the attribute of each site, including the address, the drainage area, the design spec, what types of LED there are, the maintenance log, everything will be there. So that will make it really easy for you annual reporting. Actually, the tool can actually automatically generate in the format, so you can do the annual reporting. So So that's a toolkit itself. So over past few years, we have a number of application of this tool in several major cities in the Bay Area. First one is for the city of San Mateo. We use a GIS analysis to help them identify the potential locations for their sustainable street plan. So the second application is in the city of San Jose. We apply the full toolkit from GIS analysis, modeling, optimization to help identify the cost-effective solution to control the PCB to meet their permit requirement. So over past 2 years, we have been working with 3 cities in the Bay Area, city of Sunnyvale, Oakland, Richmond, and Contra Costa County, trying to, again, apply the full toolkit to support their green structure watershed planning. So they're required by permit to develop a green structure master plan. So those analyses, including location identified, the quantified benefit, and also optimal solutions, all served as basis to go to, so they can develop based on that. Last year, we also have a very interesting application outside green structure, stormwater. Actually, we use a tool for wetland restoration planning for nutrient load reduction. This is done in the northern coast region in Laguna Santa Rosa, where the tributary to Laguna Santa Rosa. So we use a tool to try to prioritize, also identify the different wetland project site, so can reduce stormwater runoff and nutrient load to the laguna. So here's the output of that application. You can see there's a number of different types of wetland projects we identified at different locations, so can help to reduce nutrient load from this subbasin to the laguna. So starting this year, we actually have a bucket 2 EPA-funded project. So one is we called in the Livermore Valley. We are going to we call it preparing for storm. We're going to use a tool to develop a valley-wide urban greening version, which will focus on the flood control, groundwater infiltration. So the tool will help to quantify the potential water quality and quantity benefit from green circulation, and that analysis will become a foundation for their stormwater resource plan. So the last project is also we started this year is we called Healthy Watershed Resilient Bayland. This one we are going to try to explore multiple benefit of green structure and also forestry. We're trying to integrate water quality benefit and also some ecologic function for greater ecologic and social resilience. Basically, we're going to use a tool to quantify, to find an opportunity where the green structure can work with urban forestry, urban trees together. So to achieve more benefit, we're hoping we can quantify how much, hydrologic benefit of forestry, urban forests can provide, and as well as maybe some bioretention can provide some ecologic benefit as well. So the hoping is, I think the thinking is hopefully we can say the tree will be much cheaper, cost effective, because the city has to plant the tree anyway. So I know there's an emerging research area, people start to thinking tree as one of, features could help stormwater management. This is the emerging area we're heading to. So that's all my talk. So if you're interested, it's our toolkit website. You can download the toolkit itself or the documentation to help you understand how to use the tool, the structure, you use the manual to structure how you set up the tool. And in the end, here's the knowledge for the funder. First one from PAP 1840 funding, State Board, and the second current project from EPA Region 9. So here's a list of our municipal partners who have worked closely with us over the development and application of the tool. Thank you.
Do you have any questions? So I see that hand, Lynn.
I have a question about your BMPs that are going to pre-treat the PCBs.
Mm-hmm.
Aren't PCBs fairly stable in the environment? And were you going to have to go and clean out those BMPs periodically? And does that winnow down your selection of your BMPs you can choose from?
Well, I think this is a planning tool. So the assumption is, all the BMP can reduce PCB load by retaining and infiltrated all this water on the ground, right? That's a mechanism of the green structure. I think we see those pollutant soil from the BMPs, right, LIDs over time. So I think that's a very key part of the maintenance. You need to periodically take out all this dirty soil and replace with new one. But whether that has been keep doing that is keep on the good practice, that's still largely beside of planning stage. But that's a very good question. Yes, yeah.
For the load reductors for each constituent, is that based on the EPA swim model? Is where those factors are? And have you done any monitoring to try to kind of vet some of those factors and make sure they're kind of, representative of real, project conditions? My second question is for the cost benefit analyses, what are you basing the cost numbers on, or do you have to go and update that on an annual basis or something? That's
yeah,
it.
good question.
Thank you.
I think for the load, you're talking about the calibration, the model. Yes, we did. We have empirical data. We always maintain. We always say if you want to use a tool, you need to calibrate the model to your local empirical data in terms of runoff and flow. Yes. The second question, the cost we actually use, we called unit cost. We say, how many dollars, let's say $100 per square feet of irrigation surface area. That's what we use a local, we have some, local cost information. The city in the Bay Area, they, over the years, they implemented a lot of green structure, different types. They have this bidding contract or have the cost information. That's what we used in a tool. So to update it, every year, but we intend to always use current costs. Let's say if we are running a case study this year, we're going to use $2018 value versus, the old we may factor into a little bit. Yeah. Thank you.
Yeah, I noticed on one of your slides you had street trees, and it seems to me that if there was a 1-inch street tree, it's very different than a 6-inch street tree. And and you almost need to have an arborist come and look at the entire project area to evaluate that. Do you have any suggestions to ways to make that more efficient?
Yeah, that's a very good question. But remember, this is a planning tool. We actually haven't really looked into. This is a new project we just started. So currently, we're trying to figure out how to quantify trees. What are the representative trees in a watershed? Obviously you cannot to say I have 10 different species, different size. That would be too complicated. Right, we just say what is a represented a mature tree, typically in the city landscape, maybe after 3-5 years it's established. So that's the type of tree we're going to look at. So we're not going to look at the small tree versus big tree. We just say this is a more like genetic represented tree we're going to look at it.
Thank you.
Thank you. Thank you very much. Okay, we have our last speaker in this session, and then we'll have a...
Thanks very much. It's a pleasure to be here. My name's Eric Porse. I'm with the Office of Water Programs at Sac State. Fairly new there since October, so not nearly as long there as Maureen or Brian Courier's here or Kevin McChristian Carlton's here or any of these other folks too. But they've been nice hosts so far, taking me in. And then I'm also a visiting researcher at UCLA's Institute of the Environment and Sustainability. And I'm a fairly new to California. I've only been here since 2011. As things go, that's fairly new, I think. But the whole multi-benefit project makes a lot of sense to me from a long time ago because I grew up in Pennsylvania and my father managed a hydroelectric plant there, and it was along the Susquehanna River, which flows directly into the Chesapeake Bay watershed. You guys might have heard of the Chesapeake Bay, right? One of the case studies for integrated watershed management drains from a huge area. And managing this plant over the course of 25 years that he did, it was a 100 megawatt hydroelectric plant, built upgrades for 2 new fish-friendly turbines, built a fish lift working with the Department of Environmental Protection. It was osprey and eagle nest area. They dredged it behind to make sure a dam continued to function for a long time, and had downstream habitat and so forth. And you also had to deal with health and safety when boaters come up and you all of a sudden you got to spill water, because it does rain actually all year long in Pennsylvania. And so you have to spill water, and all of a sudden there's a fellow down there riding in his boat, maybe with a beverage of his choice, and you have to figure out how to manage this infrastructure for these different goals. And so this made a ton of sense, just inherently. We talk about it at the dinner table. And then I got out to California, and other than the fact that it doesn't rain 6 months a year, most stuff kind of I understood. But as I came to learn, the interesting piece of California and the West in general is that the governance tends to be maybe a little bit a layer extra of complication. Not overall, not all the time, not always true, but we do have what some might term a diverse